Hey, good morning, everyone. We're going to do lesson 12.5, volume of pyramids and cones. So in the last lesson, we did, or in actually the last two lessons, this was a couple of lessons ago, we did volume of prisms and cylinders. I guess that was 12.4. That was prisms and cylinders. So let's say we have the front of a rectangular prism, so which is going to be a rectangle. If I maybe take a point up here in the middle and draw diagonally, I am going to have the side or the profile of one of my of the side of a pyramid. Okay, and in doing that, I break it up into 1, 2, 3 parts. And so each of those parts are actually congruent. I know they may not look quite the same now, but at least go with the fact that we do have 3 triangles. And in using that same concept, that's how we do volume of a pyramid. So when we had volume of a prism, that was area of the base times height. But now we're doing volume of a pyramid, and it's got the same components. It has area of base times height, but then it has 1/3 of that. So what we're going to do is we're going to take, we can either say 1/3 times the area of the base times height, or you can go with area of the base times height divided by 3. And that's how you'll actually enter it in your calculator, is area of the base times height divided by 3. So the first example here, we have a pyramid, and we want to find the volume. Let's scroll back up here. We know the volume is, because we have a pyramid, is 1/3 area of the base times height, or area of the base times height divided by 3. Same thing. So the first thing I need is the area of the base. And so looking at our pyramid, we have to determine what shape the base is. The base is always perpendicular to the height. And you can see we have a height drawn in here and a right angle. So the base must be this rectangle at the bottom. So we want the area of that rectangle, which is its base. You notice it's a lowercase b because that's just the length of a side. Times its height. So we have 9.5 centimeters times 8 centimeters. And that's going to be the area of our base. And that is, let me use my calculator just to make sure, that's 76 centimeters squared. So that's the area of the base. So we've got this portion done. Now we just need the height. And according to this picture, our height is 9 centimeters because it's the length that is perpendicular to the base. So now I'm just going to fill in my formula. I've got the area of the base, which was 76 centimeters squared, times the height of the pyramid, which is 9 centimeters, divided by 3. So that's what I'm going to put in my calculator. And I get about, and I'm going to round to the nearest tenth here, 25.3 centimeters cubed, because we're taking area squared, and then this is actually to the first power here. So that gives us cubed. All right, so in the next one, I'll pull up a little bit different color here. In the next problem 1b, we also have a pyramid, but it is considered a triangular pyramid because the base is a triangle as opposed to a rectangle that we had in the other page. We know the base is a triangle because here is the height of our pyramid, and you can see that it is perpendicular to this side. So that right triangle there, which they got a little right angle sign, must be our base. So trying to erase it. There we go. Again, volume is 1/3 area of the base times height. And so the area of our base, our big B here, it is a triangle, and an area of a triangle, so we have to think back to our triangle areas, is 1/2 base times height. So I'm going to take 1/2. The base is 15 feet. And the height of the base, okay, so just that right triangle at the bottom there, the height of the base itself is 6 feet. 14 is the height of the pyramid. All right, so I multiply all that together and I get 45 feet squared. And then the height we said was 14 feet. That's for the whole pyramid itself. So for volume, I'm going to take the area of the base, which was 45 feet squared, times the height, which is 14 feet, divided by 3. And we're going to get 210 feet cubed. Okay, for the next one, we're going to look at volume of the cone a cone. Same thing. They try to make it look different, but it's got a circle. We know it's always a circle for the base, as opposed to maybe a square, or a rectangle, or a triangle. We're going to use that same idea. We're going to take 1/3 the area of the base times height, but since the base is a circle, the area of a circle is pi r squared, so they just substituted area of base with pi r squared times the height, but this guy right here is really just our big B, okay? So when we do these problems, we want volume. It's still 1/3 area of the base times height, but again, the base is a circle, so that's pi r squared, then times height. And so we could actually go straight to this formula. We need the radius of the base, which this is 9, and this is the height of the cone. Actually, in this particular case, this is not the height of the cone. This is the slant height. So I'm going to have to do a little bit of math here to find the height h here. Okay, this is the slant height, which just means that's the length of the diagonal there of the cone. Okay, so we are going to do a little bit of Pythagorean theorem. The h is a leg, so it would be h squared plus 9 squared equals 19 squared. So h squared plus 81 equals 19 squared is 361. And if I subtract 81 from that, I'm going to get 280. So h squared is 280, but we know we have to take the square root of both sides. And the square root of 280 is about 16.7 feet. Okay, so I think we're ready now. So we obviously needed the radius. The radius was 9 feet. The height of the cone is 16.7 feet. We found that by using the Pythagorean theorem. So now when we put our values in for volume, we have 1/3 times pi times the radius squared times the height, which is 16.7 feet. So what I would do is I would wait for the 1/3 and I would just divide it by 3 at the end instead of multiplying by 1/3. But I'm going to take pi times 9 squared, which is 81, times 16.7, and then divide all that by 3. And I'm going to get about 1,416.5 feet cubed. And kind of depending where you rounded the height of the cone, that could affect what your volume is for the cone, just slightly. Okay, for the next one, I'm also going to do volume. Volume is 1/3 pi r squared times height, or area of base times height. We're again going to have to use Pythagorean theorem because it looks like they gave us the slant height. So this is actually the height here. And because they gave me the diameter, which is 20, I need to find the radius. The radius is half of that, so that's 10 feet. So we'll use a little Pythagorean theorem. H squared plus 10 squared equals 26 squared. H squared plus 100 equals 676. And then we'll subtract 100, so that's 576. And take the square root. Is 24. So H is 24, exactly. 24 feet. Okay, now we're ready to put that into our volume formula. So volume is 1/3 times pi times our radius, which was 10 feet, squared times the height, which is 24 feet. And we'll multiply all that out. So I have pi times 10 squared, which is 100, times 24 divided by 3, and we get about 2,513.3 feet cubed. Okay, so there's how you do volume for a pyramid or a cone. It's the same formula, 1/3 the area of the base times height. Okay, you will have an assignment. You guys have a great day, and if you have any questions, please don't hesitate to message me. Bye.